In this lesson, we'll be covering the point of inflection. And the point of inflection is a point where the graph changes concavity. It changes concavity, meaning that it moves from being concave up to concave down, or concave down to concave up. So suppose we have a point there, which we've called the point of inflection, given by x and y. This point allows us to know that whether the graph is really changing concavity. On the left hand side of the green line it will be concave down, and on the right hand side of the green line it will be concave up. That's what I mean by concavity. And if let's get a different graph in that format, and suppose we find the point of inflection, this point of inflection will be somewhere there, of which its axis to y. On the left hand side of the graph it will be concave up, on the right hand side of the green line it will be concave down. So to calculate really the point of inflection, really the most important thing we'll be looking for is to first determine what the x value of the point of inflection is, and determine that by finding, I'll use the graph of f as just reference. We need to find the second derivative of the graph of x, and then we solve for the x value. In essence, solve for x. After solving for x, we substitute the x value we find into the original, and this will allow us to calculate the y value. And in that sense, we would have calculated what the point of inflection is in the sense of coordinates, really. So let's go ahead and apply what we just discussed here. So in the graph of f, we're going to be finding the point of inflection, so we need to find the first derivative, then we're going to find the second derivative, which will be negative 3x squared plus 12x minus 9. If you find the second derivative, negative 6x plus 12, so we need to equate this to 0, and we will have negative 6x plus 12 is equal to 0. Then negative 6x will be equal to negative 12. Divide both sides by negative 6, we'll get that x is equal to 12. So we found, we'll refer to the point of inflection as POI. So far we found the value of x. We don't know what the y value is, so we substitute x into the original function of f, which will be f of 2. Where there's x, we substitute 2. Plus 6, 2 squared minus 9 2 plus 4, and we plug everything into the calculator, we'll get that corresponding y value is 2. So therefore the point of inflection of the graph of f is 2 is to 2, and that's our answer. So let's go and continue expanding our knowledge really on the second question. On the second question, we need to find the first derivative first, which will be 3x squared minus 3. Then we need to find the second derivative, it will be 6x. Then we need to equate this to 0, which will be 6x is equal to 0. Divide both sides by 6, x will be equal to 0. So we just substitute really x into the original function. So far the point of contact is 0. We need to find the corresponding y value. So we just substitute it into the original function of g, which will be g of 0 is equal to 0 cubed minus 3, 0 minus 2, which will be 2. So therefore the point of inflection is 0 is 2 minus 2. Let's go to the third question. Find the first derivative, which will be x squared minus 10x minus 8, and we need to find the second derivative, of that, which will be 6x minus 10 equates the second derivative to 0, which will be 6x minus 10 is equals to 0. 6x is equals to 10, therefore x will be equals to 10 over 6, which is 5 over 3. So our point of inflection is 5 over 3, and we find the corresponding y value by substituting it into the original, which will be 5 over 3 cubed minus 5 over 3 squared is 8, 5 over 3 plus 12, and we'll get negative 286 divided by 27, and that will be our corresponding y value for the point of inflection, 287.27, and that will be our point of inflection.